So we've already started talking a lot about distance time graphs, the fact that distance is always on the y-axis and given in some kind of unit, while the time is always on the x-axis with some kind of unit. We've started discussing that if the line on a distance time graph does not have a completely straight slope like this one right here, then that means the object is changing speeds. However, what we're going to dig into today is a little deeper into what these different lines actually mean the object is doing on a distance time graph. So what we're going to do today is you're going to set up your OP page today that you're working on to make some quadrants to show me that you understand what the different kinds of lines on a distance time graph mean. So we're going to set this up first, and then I'm going to show you a series of videos so that you can go back and complete this page to show me you understand. Quadrant 1 is going to be titled the flat or horizontal line. Quadrant 2 will be titled shallow slope. Quadrant 3 steep slope, and quadrant 4 downwards slope. And as we go through the videos, you can pause at any time to write something down, rewind if you need to see it or hear it again as many times as you need. So what I want to show you are some simulations of what it would actually look like on a distance time graph as an object is moving from one position to another. You'll notice again, this is the distance in meters and this is the time in seconds. I want you to watch very closely first to what the car is doing. When I hit play, the time starts and the car continues down the path. It stopped in the middle and then continued on again. If I reset and show that to you this time, but with the markers as it's moving along the distance time graph, it would look like this. The car is moving away from the 0 position, stopped for a moment, and then continued along its path. The car ended at 200 meters away from 0 and ended its time at 10 seconds. This is what the graph would look like. Because the car traveled 100 meters, stopped for a moment, and then continued on. Now this flat or horizontal line right here means that the object is stopped because the time is continuing, but the distance is not increasing. Here's another example I want to show you. This time, we're going to watch two different vehicles moving down the road. Now, you'll notice that this motorcycle is at the starting 0 position, but the truck is not. The truck is starting at the 40-meter position. So that's exactly where the dots on the graph are going to start for distance. Because remember, a distance time graph also means position time graph. So we are looking at where the position is of the individual objects. As I hit play, both objects are continuing to move, but because the motorcycle is moving faster than the bus, the line for the motorcycle has a steeper slope. The line for the bus has a more shallow slope. You'll notice that the steep slope means that the object covered more distance in a given amount of time than an object with a more shallow slope, because the bus only got to the 140-meter position in the same amount of time. A steep slope means an object covered more distance in a given amount of time than an object with a steep sloped line. Here's another example. This time I want you to watch what the car does before I show you the graph. The car is moving up to the 100-meter position, moves back to 80, stops, and then continues and stops again at the 140-meter mark. I wonder if you can make a guess as to what the line would look like. Let's watch that again, but this time with the markers. The car is increasing distance, decreasing distance, not increasing distance, and then increasing distance again. This is what the graph would look like. It increased its distance, decreased its distance. Did you see what the car did? It moved backwards. Then stopped for a little bit. It did not increase distance, and then it increased its distance from 0 again. A common mistake that students make when they see a downward slope like this one is that the object is slowing down. That's not necessarily true. The downward slope just means that the object is decreasing its distance, basically moving back to its starting point. Here it is one more time, this time with the graph playing as the markers are going. The car travels backwards, stays in place for 2 seconds, and then moves forward again, ending at about 100 and probably 30 meters in the 10-second time. One more simulation I want to show you, and that's these two objects here. You'll notice that the bus is starting at the 200-meter mark, while the car is starting at the 0-meter mark. I wonder if you can figure out where their markers will start. I wonder if you were right. Now here's what their markers and graph will look like as the two objects are moving towards one another on the street. Now because the two vehicles crossed paths, that's why their lines are crossing. Again, because this downward slope is showing that the bus was decreasing distance from its original starting point, while the car was increasing its distance from its original starting point. Both objects were traveling at a constant speed, though they were not traveling at the same speed. I can tell because the car covered a distance of 200 meters in the time, while the bus only covered a distance of 100 meters in the same amount of time. So when you go to your quadrants, you're going to make a distance time graph that looks like this and explain if the line is horizontal or flat, then what is the object doing? And why does a flat line mean the object is doing whatever motion you set? Your shallow slope will look like this. You're going to say if the line is a shallow slope, what does that mean the object is doing? And why does a shallow slope mean the object is moving the way that you said it was? In quadrant 3, your steep slope distance time graph will look like this. Then you're going to write a description. If the line is a steep slope, what does that mean the object is doing? How is it moving?